Hi, I'm Rishabh and I'll be presenting Float, a novel approach for multi-object, multi-part scene parsing. Multi-object segmentation involves labeling each scene pixel with the appropriate object category. Multi-object, multi-part segmentation is a harder version of the problem in which object parts also need to be labeled. This labeling can be at different granularity levels as shown. The main challenges of this problem include small object part instances, as pointed out here, a long tail in the object part frequency distribution shown here for the Pascal Part 201 dataset, and a combinatorial increase in the number of labels with increasing labeling granularity. To tackle these issues, we exploit the intra and inter-ontological relationships among objects and parts. The wheels of a bicycle in the left image and the car wheels in the right image are considered different categories. However, both belong to the same part class wheel. Similarly, the cat has front and back legs, while the motorbike has front and back wheels. In this case, the spatial notion of front and back is shared. We transform these label text-based spatial notions into spatial label maps. Specifically, we run a flood fill algorithm using original label map fragments as seed regions. Finally, we obtain the desired spatial maps for the front and back of the object as shown. We do the same for the left versus right spatial regions as well. We group object categories into animate and inanimate objects which share common root parts such as head, eyes, legs, and torso, and inanimate objects which share common root parts such as wheel, body, and saddle. We also prepare label maps with root part label sharing as shown. This helps exploit within group part level similarities during optimization. In contrast to monolithic label maps found in existing approaches, we introduce factorized label maps as intermediate outputs within our framework. These consist of the object map, the part level animate and inanimate maps, and the spatial left, right, and front back maps as shown. This factorization reduces the number of labels across the dataset variants by up to 60%. Coming to Float's architecture, the first component outputs object label maps, the second component outputs animate and inanimate part maps, and the third component outputs label maps corresponding to left, right, and front back object level attributes. This is only used for the Pascal Part 201 dataset. These maps are merged together in a top-down manner to get the pre-final label map. These components comprise of the factorized network F. The pre-final label maps are refined using the inference time zoom or the IZR module to give the final output of Float. Our preliminary observation we made was that all models, including ours, tend to perform badly on small objects and object parts. Therefore, we introduce an inference time refinement procedure which doesn't require any additional training. During inference, predictions from the object level network are used to obtain padded bounding boxes for scene objects. The corresponding object crops are processed by the factorized network F to obtain per object parsing results. The resulting label maps are composited to generate the final refined part segmentation map. As can be seen, the improvement in the segmentation quality without IZR versus with IZR is evident. The parts of both objects in the scene are much better segmented. We show results with respect to the standard MIU metric and SQIU, a more fairer version of MIU. Our framework outperforms competing methods on both MIU and SQIU. We obtain incrementally increasing gains as the dataset complexity increases as well. Qualitatively, compared to the previous state-of-the-art on Pascal Part 201 BSNet, our method Float is able to segment the person category in the image fairly well, which BSNet almost entirely misses. Float also does better in correctly segmenting the side of the car, thanks to inclusion of dedicated label maps for spatial attributes. In this example, Float is able to segment the small parts of the cat much better. Notice the tail and ears missed by BSNet. It also segments the dog's legs better. To conclude, we present Float, a scalable factorized framework for multi-object, multi-part scene parsing. We're the first to show results on the full Pascal part dataset, beating the previous state-of-the-art by a large margin. Additionally, we show large improvements in parsing small and infrequent object part categories. Thank you for watching.